Hello everyone, you are welcome to this class. So in this class, we want to continue from where we stopped. We stopped at factorization method of solving quadratic equations. Now today we're going to be looking at completing the square method. So if you are given a quadratic equation and you cannot use factorization method to solve it, so this is the alternative method of solving what quadratic equation. So that's why I said that completing the square is the alternative method of solving what quadratic equations that cannot be solved by using what factorization method. So before we go into the details, we have to look at some things that involve around completing the square. If you know you have 3 squares, 3 squared means 3 times 3. And at the end of the day, when you multiply 3 by 3, you get 9. So this 9 is what we call a perfect square. Perfect square. Right? So perfect square in the sense that when you find the square root of 9, you're going to get what? 3. So we're looking at a situation whereby you want to make quadratic equations that cannot be solved by factorization method to be a perfect square. For example, x squared plus 8x. So if they ask you what number you add to this expression, this is an expression, x squared plus 8x. So what number we add to x squared plus 8x to make it a perfect square? So what that means is that we want to make it quadratic expression. For example, like adding 2 to it. So this is an expression, quadratic expression as well. We can solve this one by factorization method or the like. Now we want to look at what are we going to add to this. So to make a quadratic expression a perfect square, so there's a rule that we want to follow. And what is that rule? So we look at, this is x squared, this is 8x. So we are going to find the half of this. Half of the coefficient of x. Coefficient of x here is plus 8. What is the half of it? That is 8 divided by 2. And that gives what? 4. Then we then square it again. So we square this one, that is squared. That gives us 16. So which means that if we add 16 to this, that is x squared plus 8x, we give us what? Plus 16. So this expression has now turned to what? Quadratic, a perfect quadratic equation. So which means we can solve this using using factorization method. Let's look at this. So we want to factorize this. So we have this and this. So we have 16x squared, right? I explained in last class. So 16 is what? 4 times 4 will give us what? 16, right? So 4 times 4 gives us 16. So we can make 4x times 4x will give us 16 what? X squared. And at the same time, if you have 4x plus 4x, it will give us what? 8x. So which means we can replace this with what? This 8x. That means we are going to have x squared plus 4x plus another 4x plus what? 16. We can factorize this one. So what is common here is what? X is common to this, and this, that means we are going to have x plus 4, then plus what is common here is 4, then this will be what? X plus 4 as well. So that means the answer will get the x plus 4, then x plus 4. You can see x plus 4 is repeated twice. Because it is repeated twice, it means that x plus 4 squared. So we have turned this to a perfect square. We have turned this expression to a perfect square. So that's what we want to look at under completing the square. So we're now going to be using the concept of making a quadratic expression perfect square to solve quadratic equation that cannot be solved using factorization method. I hope that is very clear. So from what I just explained now, so if you want to make a quadratic expression a perfect square, so what you are trying to do is this: you add the square of half of the coefficient of x to that expression, just like the one we finished now, x squared plus what? 8x. So to make this expression a perfect square, you are going to add the square of half. That is going to find half of this, which is 4, then we square it, which will give us 16. So we add it to the expression. So by adding this 16, this expression x squared plus 8x has turned to what? For the perfect square. I hope that is very clear. So for example, if you have another example, like we have y squared minus what? 7y. So we want to make this expression a perfect square. So what we are excited to do is that we are going to add the square of half of the coefficient of y here to it. The square of the half of the coefficient of y to it. So what is the half of minus 7? Is what? Divided by 2. Then square of it, we square it. That means we are going to add 7 squared minus 7 squared is what? 49, and 2 squared is what? Is 4. So which means we are going to add 49 over what? Over 4 to this expression. So by adding this 49 over 4 to it, we have turned the expression to what? To perfect square. Let's now see how we're going to use this concept. The concept of what? Perfect square to solve or completing the square method of quadratic equation. I hope that is very clear. So let's now look at examples now. These are the examples we want to look at. So use completing the square method to solve the following equations. So this is 0. Now the first example we have here is x squared plus 6x plus 5. This first example is what I'm going to use to start. This one we can use factorization method to solve this. But we have to use completing the square. We are going to use factorization method to solve it first and get an answer. We see what the answers are there before we use completing the square method. And there's something I want to show you here. So by the time we get to this place, it's something we get the reason why we are doing some particular things when we are solving it. Now the first one is x squared plus 6x plus 5 equals to what? 0. So you can see the coefficient of x squared is 1. So we can have this. This will give us 5x squared. So what are the products of two numbers that will give us 5x squared? That is just 1x times what? 5x. Give us 5x squared. And when you have this 1x plus 5x, that gives us 6x. So which means you can use this to replace it. So which means this expression, this equation is what? Factorizable. We can use factorization method to solve it. So let's have it. We're going to have x squared plus x. This is x taken as 1x taken as x plus 5x plus 5 equals to 0. I hope I'm making sense. So let's factorize. This is x is common. That's x plus 1 plus 5 is common. X plus 1 equal to 0. So from here, so you see that what we have in this bracket and this bracket are the same. So because they are the same, we can have x plus 1, then x plus 5. We combine this x plus 5 equal to what? 0. So therefore, we're saying that x plus 1 is equal to 0 or x plus 5 equal to 0. Hope I'm making sense? So in that case, we're going to have x equals to minus 1 or x equals to what? Minus 5. So these are the roots of this what? Equation. These are the roots of this equation. That is x is equal to minus 1 or x is equal to what? Minus what? Minus 5. Now, that is not what we are not expected to use this. We are expected to use completing the square. How do we now apply completing the square method now? That's what I want to show you. So what we're going to do is that x squared plus 6x plus 5 equal to 0. The first condition is that the coefficient of x squared or whatever letter you are given that is squared must be 1 before you can apply it. So the next step is to take the constant to the right hand side. Move the constant to the right hand side. That means how are you going to move the constant to the right hand side? It is plus here. So for you to move it, you are going to, it will turn to negative. So you are going to say subtract minus 5, subtract 5 from both sides. So when you subtract, what you're going to have is x squared plus what? 6x equals to what? Equals to 5. So you can see that this has turned to the initial equation I gave you, the expression I gave you, that you want to make it a perfect square. Now you want to make this expression, this left hand side, you want to make it a perfect square. You want to make this expression, this one, we want to make it a perfect square. What are we going to do? We are going to find the half of this, then we square it, we then add it to this side. So because we have equation here, this is an equation, so whatever is done to this side must also be done to the other side. Am I with you? Whatever that is done to one side of an equation must also be done to the other side of an equation. I hope I'm making sense. So because we want to make this this expression that we have this left hand side of this equation a perfect square, we are going to find half of this. So we're going to say add the square, add the square of half of the coefficient of x to both sides. To both what? Sides. So what are we going to do now? The coefficient of x here is plus 6. That is 6 divided by 2. That is the half of it. So which will give us what? 3. Then square of it, square, will give us what? 9. So we are adding to both sides. That means we're going to have x squared plus 6x, are you with me? Plus 9 equals to 5. Sorry, this will be minus 5. Minus 5 plus 9. I hope I'm making sense. So, having done that, we are now going to factorize this one. You know, we have turned this to what? We have turned it to perfect square. And perfect square will be in form of x plus 2. When you have x plus 2, it's going to be squared. That is perfect square. So when you now factorize this one, we can write this one to be x squared plus 6x. X squared plus 8. When you factorize, let's factorize this one and see something. X squared plus 6x plus 9. Let's factorize this and see. So what we're going to have is what? We are going to have 9x squared, right? So which will give us product of two numbers that will give us 9x squared and also give us is what? 3x plus what? 3x. So 3x times 3x will give us 9x squared, and 3x plus 3x will give us what? 6x. So we are going to have x squared plus 3x plus 3x plus 9. Let's factorize and see what we're going to have. We're going to have x squared, x is common, that will be x plus 3 plus 3 into what? X plus what? X plus 3. Right? So that means we are having x plus 3, then x plus 3. So don't forget this one. This will give us, this one we are factorizing, this will give us 4 equals to 4 equals to 4. This means that this is x, you can see the same thing, that will be x plus 3 squared equals to what? 4. So we have factorized this one. This, what we have here now, is this. So the shortcut to it is this. There is no need for you, once you have added the square of half of the coefficient of x to both sides. So what is going to happen is that this, the middle one here, this middle term here, when factorized, it will not show again. What you are going to have left is what? X squared plus what? 3 squared. Can you see? X squared plus 3 squared. And that can be put in the bracket like this. X plus 3, everything was squared. Because 9 here is what? 3 squared. Is that clear? So that's why we're going to have this. So instead of you working this one, you just like x squared plus 3 squared. And you put everything in bracket to have this. So don't forget this x we're looking for. You can just say x plus 3. We are going to have a square root both sides. Square root both sides. We're going to square root both sides. So the square root both sides is going to have x plus 3 equals to, this is going to turn to plus or minus square root 2 or square root 4. So in that case, we're going to have x equals to, we take this to the other side, minus 3 plus or minus square root 4. So that will be x equals to minus 3 plus or minus what? 2. So we can have it to be x equals to minus 3 plus 2 or minus 3 minus 2. So x equals to minus 3 plus 2 is minus 1. Minus 3 minus 2 is what? Minus 5. Is it not the same thing with this? You can see that it's very straightforward. Don't worry, by the time you look at another example now, it will be simpler. Because you have known the basis. This is the basis. You have known the reason why something will happen now. This, when you are factorizing next time, when you have added this to both sides, so there's no point to factorize. You just know what you are going to have left after factorization is x squared and this one. This one will go. The reason why it's going is what I've shown you now. So subsequently, I'm not going to work this out. I will just, you know the next thing that will happen. Is that clear? So let's look at the other example. Example 2 now. We have x squared minus 10x plus 8 equals 0. So the same thing, you can see the coefficient of x squared here is what? 1. So it's good. It's perfect like this. So what we are going to do is to take this to the other side. So we're going to have x squared minus 10x equals to what? Minus 8. That's the first step. Second step is that we're going to find the square of half of the coefficient of x. We add it to both sides. So we add the square of half of the coefficients of x to both what? To both sides. So that means, what is the half of minus 10? Half of minus 10 divided by 2 will give us what? Minus 5. Square it will give us what? 25. So we are adding it to both sides. That means we are adding x squared minus 10x plus minus 5 squared equals to what? Minus 8 plus 25. So this 25, this minus 5 squared is what? Is 25. I'm just leaving it like this because I'm still going to make use of it. Now, by the time we factorize, don't forget what I told you. This will go, it will remain only this and this, which is what? X squared minus, because this is minus 5 squared equals to what? This minus 8 plus 25, 17. That's going to go 17. I hope I'm making sense. So in that case, what we have left is going to be x minus 5, everything squared. Don't forget. Don't answer, Mr. Akwa, what happened to this minus 10? I've shown you in the first example I explained. This minus 10, by the time you factorize this is what you're going to have left. X squared minus 5 minus 5, so that's what you're going to have left. Is that clear? So in this case, this is what we have here now. We're going to have this 17. So the next is to square root both sides. Square root both what? Both sides. So that means we are going to have x minus 5, because the square is going here, squared, then you square root this, you cancel this, equals to what? Plus or minus square root what? 17. Are you with me? That means we have x minus 5 equals to what? Plus or minus what? Square root what? 17. So it is x we are looking for, so we are going to write x equals to this minus 5 will come in and becomes what? Plus 5. That is 5 plus or minus square root what? 17. 17 square root 17 gives us 4.12. Let's look at that one. So which means x equals to 5 plus 4.12 or 5 minus 4.12. So that means x is equal to what? 9.12 or 5 minus 4.1 will give us 0.88. Alright, so that is the answer. So is that clear? I hope it's very clear. So let's look at the third example. Question number 3. We have 4h squared minus 2h minus 7 equal to 0. So you notice that the coefficient of the squared of the variable is not 1 here. So the condition that we have to make it 1. But before that, let's change this to, this is going to be 4h squared minus 2h. We take this to the other side, that becomes what? Plus 7. So we're now going to divide through by 4 so that this will stand alone. So divide through by 4. So that is 4h squared over 4 minus 2h equals to over 4, then 7 over 4. This cancels this. 2 here 1, 2 here 2. So we then have h squared minus h over 2 equals to what? 7 over 4. You can now see that this one is what? Is 1 now. So the next is that this one is saying h squared minus 1 over 2h equals to 7 over 4. So we find half of the coefficient of h, then you square it. We find the square of the half of coefficient of it and add it to both sides. So which means we're going to add half of this, 1 over 2 times 1 over 2. That's what it means. Which is equal to what? 1 over 4. Then we square it. That will be 1 over what? 16. So this is what we are going to add to both sides. So don't forget it is minus, right? It is minus, minus, minus. So this is going to give us h squared, half of this h squared minus half of 8 plus, look at what we're going to do. That will be 1 all over minus 1 all over 4 squared. Minus 1 all over 4 squared equals to 7 over what? Over 4 plus 1 over 16. Because this one will give me 1 over 16. Factorizing this one, we're going to have 8 squared, right? Minus 8 minus 1 all over 4, everything was squared, equals to what? We find the LCM of this, which is 16. So 4 in 16 is 4. 4 times 7 is 28. 16 is 1. That is 21. So we have 8 minus 1 all over 4. Everything squared equals what? 29 over what? 16. So that means 8 minus 1 all over 4. We then the square root of it will then equals or minus 29 over what? 16. So that means we have 8 equals to 1 all over 4 plus or minus square root of 29 all over what? Square root of 16 is what? 4. Therefore 8 will then be 1 all over 4 plus square root of 29. And square root of 29, square root of 29 is equal to 5. Let's say 5.4. We use 5.385. So let's say 5.4. 5.4 all over 4, or 1 all over 4 minus 5.4 over 4. So this will give us the value of 4. This is 4. 1 plus 5.4, or 4. 1 minus 5.4. So that means we have this. So 1, that is going to be 6.4 divided by 4. So 8 here we have 1.6, or so 1 minus 5.4 minus 4.4 divided by 4 will give us what? Minus 1.1. So this is the value of this is the root of the equation. So we go to the the last example now. We have 1 over 4x squared minus 1 over 2x minus 13 equals to 0. So the first thing we think of is how can we remove this 1 over 4? So we have 1 over 4. So what can we do to make this one is multiply by 4. So this cancel this, turn into what? 1. So it means we are going to multiply through by what? 4. So multiply through by what? By 4. So that's going to be what? This will then turn to x squared minus what? 2x. Because when you have half times 4, 2 here 1, 2 here 2, that will be 2x minus 13 times 4, that is 12, that is 52. Is that clear? So this will then turn to what? 52 equal to 0. So we can then have this, that will be x squared minus 2x equals to what? 52. So we find the half of this, then we square it. What's half of 2 minus 2? The half of this over 2, then we square it. So that means we are squaring minus what? 1. So we add this to both sides. So add minus 1 squared to both sides. So that's what it means. So we're going to have x squared minus 2x plus minus 1 squared to both sides. That's 52 plus minus 1 squared. So right, so this one will then turn to x squared minus what? Minus 1 squared equals to 52 plus 1. So this will give us x minus 1, everything squared, equals to what? 53. So we can then have x minus 1 equals to plus or minus square root what? 53. So that means x equals to 1 plus or minus square root of what? 53. It's so simple, right? So that means x equals to 1 plus square root of 53. Square root of 53 equals to 7.2. 7.3, or 1 minus plus 7.3. So we have 8.3 or minus 6.3. Exactly. So this is the answer, and this is where we're going to stop in this video. If you find this video useful and helpful, don't forget to give us a very big thumb up. And if you are new to this channel, don't forget to subscribe. And make sure you share this video with your loved one so we meet in our next class. Bye for now.